Good morning. This is George Blake, Whiskey 6 Bravo Delta Delta. I'm going to bring to you a video about rebuilding a Collins 30L-1 linears. To preface this, I am not a builder of linears. I am not a repairer of linears, at least not from a commercial standpoint. This is strictly for my own use. The video is for everyone else's information. Again, I don't have anything for sale, so I'm not taking any sides on the designs or the improvements of these things commercially. So I'm just here for information, letting you guys know what I'm doing. If you have any useful comments, that's appreciated. If you don't, well, I would say move on. So anyway, I am in Olathe, Kansas. This is Thanksgiving Day, so happy Thanksgiving. And so let's get to it, go through what I'm doing here. So I'll switch over the camera view here. There we go. My drab little workshop. Busy little bench. I just cleaned it a couple months ago, and it's all cluttered again. So that's the way of a hobbyist. So as I said, I bought two Collins 30L-1 linear amplifiers from David Schulman auction. I've bought other items before. I bought my Gonset 101 linear through David. They're very, very good about checking the equipment and giving you an appraisal of what condition it's in. And so they check these amplifiers out. This is the first one, as you can see. I'll zoom that down a little bit there. That's the first one. I've already started to disassemble it. The second one's on the floor. I'm keeping that assembled in case I run into trouble. On this one, I can go back and refer to it. So I bought one for $200 and I bought the other for $250. Both amplifiers are working. At least they were working, this one. The tubes were soft. After checking the tubes, I found 3 out of the 8 were good. Threw the rest away, and we're going with that. I have another set of tubes from the Gonset that are still good. I replaced them. One died. The other 3 are good. So I do have a set of 4 good tubes for testing. The Collins is a very, very well built amplifier. It's been around for a long time. A lot of people swear by him. And it's a good, solid design. There were a couple things that I did note that I'm definitely going to improve upon. I'm not saying that they're necessarily a bad thing, but for the 1950s, they were good. For the 2000s, 21st century, maybe not so good. So we'll go into it here a little bit. So the first thing I noticed on these linears is that there is no, I don't know why my finger keeps getting in the way. There's no standby switch. There's only a power on off switch. There's no power indicator. So there's a toggle switch to turn the power on. There's no way to keep the linear in hot standby or in bypass if you don't want to run the linear but keep the tubes warmed up. So I am going to open up that opening, which is where that switch goes. I'm going to put another toggle switch in, which I've already purchased. It's on its way here. And the second toggle switch is going to be a standby. And that's going to go right here. So I'm going to notch this big enough for the other toggle switch. Oops. I've also ordered a couple of power indicators that are going to go in there because unless you're watching the meters, you won't know if the power is on or off, if the fuse blows. Or you can open the top cover and look inside at the tubes to see if the heaters are on. Other than that, you have no way of knowing if your power is on or off. So yeah, indicators. By the way, I tried to find anything that talked about disassembling the front panel on YouTube, on the internet, on blog sites, and I didn't find anything. And there's a very good reason for that, and that's because they try to build this chassis as a uniform chassis. Unique construction. It's all spot welded, so there really is no way to disassemble that front panel. There's no way to remove the front panel without cutting it apart. So anyway, that raised another question: how to get all the RF parts out, the tank circuit, the high voltage circuit. Well, what I believe that Collins did is that they built this on a form, probably just a front panel by itself outside the chassis. And once they soldered all the parts together, they slid it back in just like I slid it out. There's only two wires that run to the whole assembly. That's the output coax of the high voltage, and the high voltage lead that goes in, which goes over here to the plate connections. This has one 100 ohm resistor with a suppressor coil around it for suppression. I'm thinking of changing that to two 49 ohm resistors with two coils to each individual plate. That will also help separate the circuits for any oscillation that might occur. I think there would be some mutual coupling between the plates going there. That's going to change. The high voltage wire here is 22 gauge with Teflon tubing. Not my idea of high voltage protection, high voltage capability. So I've got some 30 kV high voltage wire here that I've used in the GON set and also at work. And it's going to replace all the high voltage wire that's in the chassis. The fan is in good shape. It works. It's a little tight. It just hasn't been oiled in a while. So this is not a sealed bearing fan. It has a little hole here for oiling. It has some kind of wicking agent inside that goes around the shaft. So just some machine oil in there, 3-in-1 oil or whatever, a little oiling tube, and it'll be good to go. Inline suppression, capacitor to ground, that's okay. We'll keep that. This is the feed through for the high voltage from the high voltage section. This is just a standoff, which is part of the interlocks. So let's talk about that for a minute. The interlocks are these clips. They're in several places that go on like that. And when you open a panel, it shorts out the high voltage to ground. That's might have been okay in the 50s, but not today. Nope. That's going away. First of all, if you have these open, turn the high voltage on, and these things go to ground, you're going to find probably blown diode stack from the high voltage section, maybe even a blown transformer secondary. There's only one real panel that you need to get access to that needs an interlock, and that's the one that's going to go into the tubes, and that goes from the top. This is the bottom view. And I'm going to put an interlock switch in, and that's going to kill the primary of the transformer, the AC coming into the primary, which will in turn kill the high voltage. That's much better method than this. Probably the cause of a lot of parts being damaged or parts being blown, catching on fire. So yeah, we will eliminate those. Talking about the high voltage section, so what we have is the transformer goes out, and it goes through, those are the capacitors and the bleed resistors. Let's turn this around carefully. This goes around to the diode stack. I'll move the AC switch out of the way. So they had to stack multiple diodes because of the low current of each of these, and they had a habit of blowing. So you stack multiples of these, they drop voltage across them. Capacitors to prevent any AC, high frequency AC arcing, and suppress the diodes. I've actually seen resistors and capacitors. My GON set, I put resistors across the few diodes that I use. I use 2 diodes. They're 3 amps, high voltage. Got little resistors just for parasitics in case wind blows. This whole board assembly is going to go away, as are the capacitors on the back side. I'm getting a Harbach electronics module, complete board. It's a board, capacitors, fewer diodes, higher voltage, higher current diodes, capacitors and resistors. It's going to have, well, the Collins has 100 microfarad capacitors in series, 6 of them. So that gives you about 16 microfarad of capacitance total, because they are in series. The Harbach is about 330 microfarads. Well, there's a couple of versions. There's a 220 and a 330. I think I bought the 330. So 330 divided by 6 is what? About 50? Much higher capacitance. It's going to be a lot lower AC ripple. The more capacitance you have, the less AC ripple you have, because the capacitors are used to filter the AC. My GON set has 5 10,000 microfarad capacitors, so I've got a total of 2,000 microfarads of capacitance. And I have about 5 volts of ripple on 1700 volts. And that would be nice in here, but there's just not enough room for the capacitors. So we're not going to get that high, but it'll be significantly better than 16 microfarads. I can guarantee you that. So with this gone, the whole new capacitor set is going to be on the back side. That'll free up this area. There'll be a soft key board that'll mount in this area. And that will help alleviate the problem with the key-on relay. This is a negative 170 volt supply. So that's used to key the relay and also to bias the tubes. Let's talk about the tubes for a minute. So I've heard a lot of people say, oh, Collins are a grounded grid amplifier. No, it's not. Anybody that thinks so needs to go back to electronics school. Need to have their heads examined. It's not. This is totally different from a Meritron. This is much like my Gonset. So there's a negative 170 supply. It's negative 130, negative 170, which goes through the relay. This is the transmit receive relay, transmit standby relay, if you will. And there's a resistor here, and there's another resistor over here across the standoffs. 39 ohm and 2K ohm resistor is a voltage divider, and that's across the relay. So normally you would bias the grids with over negative 100 volts. That's cutoff. So that cuts off the tube, prevents any operation. When you key on the transmitter through ground, which we'll discuss that in a few minutes, through the phono connector to your radio to ground, it grounds the relay, which in turn keys the relay, and the voltage divider going to ground now puts negative 3 to negative 4 volts on the grids. Negative 4 is ideal. Negative 3 works. Negative 4 is better. And that's what, again, what I have in my Gonset. The Ameritron does not work like that. And Ameritron has a lot of problems. People blowing diodes. So what this does is this runs off of a grounded center tap filament and provides 6.3 volts AC to this bus, which is your heater. And you modulate the filaments when you transmit. The grids, when they operate, are at negative 4, like I said, and that allows electrons to flow through the tube. And then when you stop transmitting, when this relay goes back into standby, your grids get cut off with a negative 100 plus volts. The Ameritron, what they do is they take the center tap of the filament transformer, they run a stack of 6 diodes, which gives them approximately 6 times 7 is 4.2. So they bias the filament supply positive by the same amount of volts that you're applying here to the grids that are negative. So you've got a differential. You've got to have a differential between the filament and the grid of approximately 4 to 6 volts. There is no cutoff on the Ameritron, except for just killing the RF input. So this kills the RF input, but it also puts these tubes into cutoff. And when you turn this on, it puts the grids at negative 4, negative 3, negative 4 volts. This is, I think, a much better method. And it's obvious the Collins has been working a very long time. Almost no issues, except for when you have age problems. Meritron, not so much. Another thing I'd like to quickly discuss is this idea that a 572 is a better replacement than the 811s. I disagree. And I defy anybody to show me where a 572 is better than an 811. And I have the tube data sheets to prove it. The extra 1,000 volts you get is not any kind of gain at all. Any measurable kind of gain, I would say, that is useful. So you might get half a dB, maybe 1 dB more if your antenna is perfectly tuned, if all the conditions are right, if you hold your finger up in the wind, the right direction. Otherwise, the extra 1,000 volts change in the power supply, the extra 1,000 volt protection, the additional cost of the tubes, because the 811s are much cheaper than the 572s. It's not worth it. My Gonset proves it. I get up to 800 watts out of my Gonset with the improved power supply. I'll probably get close 600 or 700 watts when I get done out of this thing. I like this design, the Gonset, the Collins, the Loudon Boomer. Several others have made the design with the cutoff on the grid. We're going to put gas discharge tubes from the filaments to ground, also from the grid to ground in case of a plate to grid or plate to filament short. Instead of taking out the power supplies, it will arc the ground, and that's the worst thing that'll happen. It'll probably blow a fuse, which I'm going to put in. I'm putting 1,000 volt fuses in on the main power supply. So I've got some 2 amp and some 3 amp that I just bought with pigtails. I'm going to utilize the standoffs that are going to become unused for the interlocks for accomplishing that. And I'll probably put the fuse directly out of the high voltage stack once I get it installed. Protect the high voltage stack and the transformer. I was thinking about putting it between the stack and the transformer, but the inrush current may blow the fuse. They're slow blow, they're ceramic fuses, but I'm thinking just put it on the output going to the high voltage section will be fine. So that's some of the changes and improvements I'm going to do. Another one is, let's talk about this again. So, phono jacks. So you've got a PL259 UHF connector for the output. You've got a phono jack for the RF in, which is not a 50 ohm connector. They did use 50 ohm coax, but yeah, I'm going to make that bigger. Put some kind of a PL259 on there. The ALC and the relay key connections, I'm going to change those. Probably BNCs is what I'm thinking. The soft key or the soft key circuit will isolate the negative 170 from the radio. It's never a good idea to run high voltage out to anything outside of the chassis. If I had my druthers, I would change that also, but the Gonset also uses negative 100 volt DC relay for its key on off. And I changed its circuit, so it's a lot better. I put a DIN 4-pin connector on my Gonset for that, out of my Yaesu. Might change some of these carbon resistors to a non-inductive flame-proof, just because the tolerance is tighter. These are plus or minus 10%, 20%. I can get down to 1 or 2% with non-inductive flame proofs. That'll be better. A lot of loose hardware. Let's see, which one is it here? One of these sockets, the hardware is loose. There you go. So there's a lot of loose hardware in here. It's old. It's from expansion, contraction due to heat. Things will get loose. I have a cold solder joint down here. That's not real good. Now if that's for filtering, which it is, so there'll be a little bit of resoldering going on. Clean up, check some of the wires, make sure I don't have anything that's aged and cracking. Again, because this will be gone, I can put the high voltage cutoff relay in here. Fuses are good. Cord is going to get replaced. I don't know how old this cord is. That's one thing I don't trust, is AC cord with age. I see the insulation inside just disintegrate. Had a Weller soldering iron, all the wires in it disintegrated, and I turned it on, it started smoking. That's not a good thing. So yeah, the capacitor, going to change that. Somebody put duct tape around it, probably just for isolation protection, but yeah, that could be dressed up better. So when I get it all done, I should have a much better operational amp and a lot more longevity out of it. One of these is going to go to my ham club, Whiskey 7 Arizona State University, W6 ASU. I'm in the Amateur Radio Society at ASU. I'm taking my degree online to finish it up once and for all. At 64, I'll probably be 65 or 66. I'll get my degree just in time to retire. But when I retire, I plan to maybe do some part-time teaching or some consulting work. So this is what I'm doing. Again, if you have any constructive comments, feel free to take them and make them in the comments area. And this is the start. So this is kind of like part one. I want to get the Harbach board in and get that assembled and get it tested, and then start putting this back together. I'll do part two. Probably show the AC circuit active without the high voltage being active, and show you where I mounted everything. So that's all I got. Thank you for watching and listening, and we hope to see you again soon. And again, happy Thanksgiving, happy holidays, happy Hanukkah, Kwanzaa, Merry Christmas, Happy New Year, all of that. Thank you. W7 or W6BDD, Whiskey 6 Bo Diddle Diddle. I'm signing off.